Hello, everyone. I want to welcome you to our session on thermodynamics. This is week 3, and we will be looking at types of system boundaries. But before we dive right straight into that, we want to look at types of system. And you see, it is actually the type of system boundary that defines the type of system. Here we see open system, closed system, and isolated system. This open system is called open not because of the system, but because of the nature of the boundary. The closed system is closed because of the nature, right? Because of the nature of the boundary. And the isolated system is isolated because of the nature of the boundary. So this is an open system. Sorry, this is hand drawn, and sometimes I prefer so that everything doesn't look artificial. So let's look at the open system. We have mentioned it earlier, but now we'll look more closely at it. The open system is open because its boundary allows for the exchange of matter with the surrounding. It also allows for the exchange of energy. And energy is exchanged between the system and surroundings as heat or work. We come to the closed system. The system is closed because its boundary does not allow mass interaction with the surrounding, but it allows energy interaction. And that is in form of heat and water. The isolated system is isolated because its boundary does not allow for exchange of matter, neither does it allow for exchange of energy, that is, heat and water, with the surrounding. So those are the types of systems we just want to mention here. And then let's go straight to our main focus, which is the types of boundaries that define the system. A boundary can be permeable or impermeable in relation to matter. We may not look at semi-permeable. We just take it for this discussion. Once it's permeable to any material at all, we will call it permeable. And when it is totally impermeable to any material, we call it impermeable. So in relation to heat, a boundary, the same permeable or impermeable boundary can be diathermal or adiabatic. I'm sure you are used to adiabatic, where the boundary does not allow the flow of heat across it between the system and the surroundings. Now, the very opposite of that is diathermal. When a boundary is diathermal, it allows for heat exchange. The same boundary can be either movable or rigid in relation to work. So, a boundary can have various combinations of the properties. So let's look at some of them. A boundary can be permeable. That means it allows matter. The same boundary by its nature is adiabatic. It doesn't allow energy exchange in form of heat. Then the same boundary can be movable. It allows energy exchange in form of work. So what do we call this kind of system? The system is open because it can exchange material and energy, right? With its surrounding. Now, if we take another example, look at this. If you have a permeable boundary that is diathermal and rigid, this system is open because it allows material exchange. The boundary allows material exchange, and the boundary also allows energy exchange in form of heat, but it doesn't allow energy exchange in form of work. So once the system can exchange matter and energy to the surrounding, known as an open system. Okay, let's look at the third example. If the system boundary is impermeable, diathermal, and rigid, what kind of system is that? Impermeable means it doesn't allow for material exchange with the surroundings. Diathermal means it allows for energy exchange in form of heat. And rigid means it doesn't allow for energy exchange in form of work. So this system with this third property combination is closed. It's a closed system. So we could just go back a bit and see an open system allows for everything. In fact, it could even be imaginary because it is not a barrier in any way. Anything can move, both matter and energy. A closed system is kind of in between these two. So it only allows for energy in two forms. The two forms of energy in motion are heat and work. So we look at this third one, isolated system. Here, the boundary is impermeable, right? Rigid and adiabatic. For this second one, let's go. The boundary is only allowing heat and work. So it is impermeable, yes, diathermal, and movable. This first one, the open system, the boundary is permeable, diathermal, and movable. Okay, so we can go back now to where we were. So the various combinations of the property of the boundary will tell us the system. Okay, let's look at special cases. When you have a case where a boundary, I just mentioned it a little while ago. When you have a case where the boundary is impermeable, it's adiabatic, and it is rigid. That system is isolated because all manner of interaction have barrier and cannot allow. Second special case is just the reverse. Where your boundary has, the boundary is permeable, so material can go in and out. The same boundary is diaphragm, so it can go in and out. And the same boundary is movable, so it connecting work. This is an open system because there is no barrier to any form of interaction with the surrounding. Yeah. there is something that is worthy of note. And that will just take us back to the step. Now, if you have a system whose bound, look at this first one, it's permeable, adiabatic, and movable. We said it allows for mass interaction and work interaction, but it doesn't allow for heat interaction. There's a special issue on this note. Once a boundary is permeable and matter can be exchanged in the surroundings, because the matter carry along with it, some enthalpy, which is heat in motion, then the adiabaticity of the boundary is ineffective. What I mean is this. If you have a boundary that does not allow heat flow from the system to the surroundings, or vice versa, if, however, that same boundary allows material to flow into it from the surrounding or out of it, that material carries heat with it as it flows. It's really enthalpy, but because it's in the matter and it is moving, it is also. So a permeable boundary cannot effectively be adiabatic. That's the point here. The permeable boundary is automatically, by effect, diathermal. So we can conclude now that the properties of the system boundary define the type of system. Sorry, there shouldn't be S. The properties of the system boundary define the type of system you have. Okay, thank you and see you in the next highlight.